Hello friends. Today's project is integrating and developing the low-cost battery charging circuit in IoT device design. We will develop a single-cell battery charging circuit at very low cost, as low as 60 to 70 Indian rupees. At one end connect USB, and at the output connect a lithium-ion single-cell battery to be recharged. This simple circuit will charge the battery connected at output. You can also integrate this small circuit with your IoT project design, in which a battery is used for power supply and enjoy uninterrupted operation. The main chip used in this circuit is MCP73811 or MCP73812. You can program current and take output with the help of these 5 pins and recharge your battery. From the datasheet you can see this chip is used to charge a single cell battery. Apart from this, only 2 ceramic capacitors and 1 resistor is used to develop this project. You can integrate this circuit with this type of small sensor node. This type of circuit runs over small batteries, hence including this battery charging circuit will help. We have used MCP73811 for this design. If you need 500 mA at output, you can use MCP73812. This is a 5-pin IC and VDD pin is input pin, and V battery is the output pin that will be connected to the positive terminal of the battery. VSS is a negative pin and will be connected to the negative terminal of the battery. This is the 3D view of the circuit. Here you can see this coin-shaped board designed by me for an IoT sensor, integrating the battery charging circuit. This is the programming pin using which you can program the current. Here we are using a resistor to program current on our circuit. 2 capacitors of value 4.7 microfarad are required at the V battery pin. This chip provides 3 types of charging modes: constant voltage mode, charge termination mode, and automatic recharge mode. This is the equation which is used to calculate the value of the resistor. So depending upon the charging mode and the output current required, you can calculate the value of the resistor used to program the current. For 3.3 volt battery recharge you need to have a 2 kilo ohm resistor. For the MCP73811 chip no resistor is required. This is MCP73811 IC. These are all the components. In the circuit diagram you can see a status LED that represents charging status. This is optional. After designing the PCB, the next step is to solder the components. While charging, this circuit will not supply power to load. If you want that battery to charge and the power is also available at load at the same time, then you need to add an additional circuit to it. If you don't want this feature, then just add one switch to the previous circuit. When the switch is off, you can charge the battery. Let us see the demonstration. This is the battery charger integrated IoT sensor developed by me. I have connected this board to charge the battery. You can see the status LED is showing that the battery is charging. This is all about this project. We hope you liked it. Do implement this project at home and let us know your experience. Thank you.